Hi, today we are going to learn about how to measure angles. So first I'm going to start by looking at the formal definition of what an angle is. An angle is the union of two rays that have the same endpoint but are not both subsets of the same line. The common endpoint is called the vertex of an angle. So if you look over at the picture on the right, diagram on the right, you can see that I have two rays here drawn with a common endpoint Q. So in looking at this, my ray QP and my ray QR, the union of that is going to form this angle, PQR. Now, the other thing I want you to notice about this definition is it does not allow my angle to be straight. These 3 points here, P, Q, and R, cannot be collinear. That means they cannot lie on the same line. Now, if the 3 points, P, Q, and R, are not collinear, then the union of the rays QP and QR is an angle with vertex Q. Again, this is the vertex. This angle is denoted by either PQR or RQP. Notice in each of these cases, the vertex is listed in the middle. Those both represent the same angle. So that is angle PQR, angle RQP is equal to the union of ray QP and ray QR. Now, angles are discussed in traditional geometry. So in your traditional geometry section of your notebook, I would like you to put this entry. An angle is formed by two rays with a common endpoint. In traditional geometry, they do not have the qualification about these points not being collinear. We would be allowed to have a straight angle. But in EMF, in our textbook, it does not allow that. And in traditional geometry, we name these angles similarly. So this would be angle ABC or angle CBA. And again, B is the vertex. But we are also allowed to call this angle B. So we can name an angle by its vertex so long as there's not more than one angle that has that same vertex in the diagram. So the next thing I'd like to talk about is circular orientation. So we say that for distinct points A, B, and C on a circle, the ordered triple ABC has a positive orientation if the motion on the circle from A to B to C is counterclockwise. So counterclockwise goes that way. And if we look over at this picture, it says points PRQ, RQP, and QPR have a positive orientation, and ordered triples PRQ, QRP, and RPQ have a negative orientation. So I didn't really finish this before. So if our points are moving in a clockwise rotation, then it is considered negative. If it's counterclockwise, then it's positive. So as I look at this, P, R, Q, we're going around the circle counterclockwise. RQP, counterclockwise. And QPR, again, counterclockwise. Those have a positive orientation. So counterclockwise is positive, clockwise is negative. So how are we going to measure an angle? We've been used to measuring lengths with a ruler. So one natural way of thinking about it would be to measure an angle with a circular ruler. In this case, I have a picture drawn. and I have my angle here with vertex at the center, and I have this circular ruler here, and my radius from the center to the point on the edge of the circle is 1, or the radius is 1. And then I have some coordinates on my ruler. P and Q are coordinates on the ruler, and point P and Q line up with those coordinates. So we're going to look and see if there's a way that maybe we can measure the angle with a circular ruler. So let's take a look at what happens when I have a circle with a unit length equal to the diameter. One idea is I could take that circle and I can roll it along the line or the coordinate system and transfer that onto the circle. So let's see how that looks. So I start at the origin, it's rolling, it's rolling, it's rolling, and you can see that we end at pi because the circumference of a circle with the diameter of 1 is pi. Another option is to let the radius be 1, and actually in trigonometry it's much more common to work with circles with a radius of 1. So how would that look? Let's take a look at that. So it's starting at the origin at 0. We are transferring our coordinates onto our circle, and all the way around would be 2 pi. Now, so for each y in the interval 0 to 2 pi, including 0 but not 2 pi, if y is a point on the line whose coordinate on L is y, then we assign that coordinate y to the point x of the circle that at some moment touches y during the course of this rolling. We say that y is the circular coordinate of x. So we could potentially transfer all those coordinates onto this circle. So some vocabulary would be the U circumference. So what that means is the U length of a circle is equal to the U circumference of the circle, unit length of the circumference of the circle. If the circle starts at the origin O and after one full revolution arrives at the point P, then the U circumference of the circle is the distance between O and P. That is the U length of the segment OP. So the U circumference is the distance around that circle. So now I'd like to give you guys some time to work. I want you to do exercises 94 through 97 of your book. Have a great day.